Hello, this is Mr. Huber. In this video, I'm going to go through an answer key for the recent timed quiz on the 6 trig functions and the work that went along with that. These questions are not necessarily in the order you would have seen them because they're randomized on the quiz, but these are the questions you would have seen at some point during the quiz. So, first one, find the exact value of secant 210 degrees. All right, so for problems like this, right, we want to know that this is secant 210. That's a reference angle of 30 degrees, and it's in quadrant 3. Right? 210 degrees, or that'd be something around here, with our reference angle here of 30. Okay, and secant, all right, is the reciprocal of cosine, so it's r over x. Right, so we need the x value and the r value for this. This is where we'd use a 30, 60, 90 triangle. So if we have one 30, 60, 90 triangle drawn out, we'd be able to use this all the time if you need to redraw one, or you might not even need to redraw it at this point if you're getting familiar with these. All right, and then we have square root of 3 over 2. That's squeezed in there a little bit. But so the x value is square root of 3 over 2, and the r value is 1. So this would be 1 over the square root of 3 over 2. That's 1 times 2 over the square root of 3, multiplied by the reciprocal. Dividing by a fraction, same as multiplying by the reciprocal. And so then we would need to rationalize this by multiplying by square root of 3 over the square root of 3. We'd have 2 square root of 3 over 3. And the last thing to think of is what sign should I have on my answer. You can use the all students take calculus if you want to know whether x and y values are positive and negative in different quadrants. Okay, so in quadrant 3 over here, we'd have, if we do the all students take calculus, tangent should be positive. Since secant's reciprocal of cosine, it would be positive, or cosine's positive in quadrant 1 and 4. And in quadrant 3, it'll be negative because we'd have a negative x value. Negative x value would be in quadrant 3, so we'd have negative 2 square root of 3 over 3. Okay. Next, find the exact value for cotangent negative 135. All right, so negative 135 be out here. That'd be negative 135. That's a reference angle of 45 degrees in quadrant 3. And cotangent is the reciprocal of tangent, so it's x over y. All right? And when we have a 45-degree reference angle, hopefully we're getting familiar with these, where we would know that this is square root of 2 over 2 and square root of 2 over 2. So when we have a hypotenuse, the radius of 1, both legs are going to be congruent. So when you have the numerator and denominator here are both equal to each other, it's going to be equal to 1. Tangent is positive in quadrant 3, so is cotangent. So your answer would be a positive 1. All right. Find the exact value of cosecant 540 degrees. So if we take 360 degrees away from this, we'd have 180. Because going around 360 just gets us back to where we started. So this is really the same thing as 180 degrees. So 180 degrees is this point right here, negative 1, 0. There's no reference triangle. There's still an x and a y value, and the r value is 1. Cosecant is the reciprocal of sine, so it's r over y. So radius 1 over y value of 0, so that's undefined. Okay. Undefined would be your answer for cosecant of 540. All right, then moving on here to number 4. So find the value of the product of tangent 100 degrees times cotangent 100 degrees. These are not special angle measures. We don't need to know what the actual ratio is for tangent 100 and cotangent 100. We're multiplying reciprocals. Tangent and cotangent are reciprocals. So if you multiply reciprocals of that same angle measure, it will always come out to 1. Or anytime you multiply reciprocals, your answer will be 1. Next, we have the secant ratio is negative 13 over 12. And on the quiz, it would have been written like this. Okay, it doesn't necessarily mean that the 13 is the negative. The fraction is negative. Okay, and so secant is r over x. Okay, the radius is never going to be positive, so the radius here is 13. The x is 12, and we can do x squared plus y squared equals r squared and solve for y is 5. Okay, so it's a y value of 5. All right. And we're in quadrant 3, we want to find cotangent. So cotangent, all right, is x over y. So we take our x value of 12, our y value of 5, And in quadrant 3, it's going to be positive because we'd actually have a negative x and a negative y. So we have positive 12 over 5 for the cotangent ratio in quadrant 3 that goes with the secant of negative 13/12. All right, moving on to the next problem here. Number 6 says simplify the expression below to a single trig function or number. All right, so what we'd want to do on this one is cotangent can be written as cosine over sine times sine. We can put it over 1 if it helps recognize those will simplify, and we just have cosine theta. That'd be your answer. That's simplified to a single trig function in that case. In the next problem, we can multiply these together. Okay? This is a special pattern of product of binomials. You're going to get cosecant squared theta minus 1. If you FOIL it all the way out, the two middle terms will cancel, and this is what you would have for this, cosecant squared theta minus 1. That's not a single trig function or number yet. We still have a little bit of work to do. One of our Pythagorean identities is 1 plus, not cosine, cotangent, so 1 plus, erase that, cotangent squared theta equals cosecant squared theta. And if we subtract the 1 on both sides, that cancels. Cotangent squared theta equals cosecant squared theta minus 1. That's what we have right up here. So this is equal to cotangent squared theta. That would be your answer for simplifying that to a single trig function, in this case of cotangent squared theta. All right. The next problem here, number 8, find the exact value of the function below for an angle in standard position whose terminal side contains the point -8, 6. Okay, so if we look at this, -8, 6 would be out here in quadrant 3. We have a in quadrant 2. Let me fix that. All right. Quadrant 2, because a positive y value. Okay, so we'd have -8, 6 out here, -8, 6. All right, and so 8, 6, we could solve for the r value of 10. All right, so we want to find the function for cosecant theta. Okay, cosecant is r over y. It's the reciprocal of sine. So the r is 10, the y is 6, so that would simplify to 5 over 3. Right? And so we can make sure that we're write positive or negative sign. We could have done that here with our r and y values because r is positive, the y in quadrant 2 is positive, so it should come out to positive 5/3, and sine is positive in quadrant 2, so cosecant would be positive in quadrant 2 as well. For the last one here, this is where you're going to use your calculator. We don't have a special angle measure or anything for this, so we need to recognize this is the same as 1 over tangent 53 degrees. Reciprocals. So since cotangent is the reciprocal of tangent, it's going to be 1 over tangent 53. Okay, and so you can just put that in your calculator, and you're going to get thousandth place is 3 decimal places, so 0.754. Okay, would be with that round, so because it's 0.7535, so the 3 would get rounded up because of the 5 after it. Okay, that's a run through of the different problems that were on that quiz. If you need to go back and look at any of those, rewatch any of the parts there, and if you're still having any difficulty with any of it, you can follow up with me and let me know where you have further questions.